Alright guys, today another episode of my progress on the batteries. My system is already up and running, but as you can see we're getting ready for another battery stack. Total 11 kilowatts, that's progressing quite well. Well, what we've seen thus far is that charging with the Opus chargers is time consuming. I've got four. That means that 4 times 4, 16 batteries in one go, and that's just not enough. One complete rack of 11 kilowatts. We need to charge approximately 1200 cells, and that's actually taking weeks and weeks. Not only quite a burden, not on myself, but also on my family. I put my spouse to work, my kids, if they see that the batteries are actually full, they're swapping them out for me. They're also filtering, plus seeing if they are damaged or not, but different video on how we actually do that. And I wanted to expand on actually delivering the other two 2200 kilowatts and in the future also play with the batteries going forward. So Opus, great, a lot of recommendations, but what I actually went for is the MegaCellCharger. Been manufactured somewhere in China, assembled in Czech Republic or Romania, somewhere in Europe, and I got a couple of shipped. One is already on my desk, and this one is a second one that we actually want to deploy and be able to also do some testing with them. I've already pasted on Facebook some information, including the links, but when it's actually being shipped, it comes completely bare. There are a few 3D printed components, and as you can see here, those are heat sinks for discharging, connected with a few 40 millimeters of fans on the board, which are actually dissipating the heat generated. In the middle you'll see that there's a small LED, or LCD display. It's protected by a small plastic cover, and underneath there's a wireless controller, an ESP32 as far as I can see, which is allowing you to communicate with this board wirelessly. I will enroll the boards and then capture the video how to do that. And once it's enrolled, you can also access this through the application developed to manage it, and also through a web interface if you want to. Now, I've already set it up yesterday. I've done some testing, and what I noticed is that the communication with the version 1.5 of the firmware and the application itself is not 100% reliable. Not sure why yet. I have in the meantime written some other code to actually read this board and do some graphing, because that's not included in the original software. So hopefully that will help. And yeah, running now a complete discharge on the cells to capture the actual data, see if that adds up. Also we can see how much voltage differences is between measurements, and then we'll see. The first observations I have thus far with this board is that it's okay, even though they have some 3D printed components. It rests well on the desk. You see a small crystal here, and that is not touching your desk due to the brackets that are installed. So that's great. These are the resistors that are being used for dissipating the battery charge. And when you look closer, you see a few chips on this board, which we will go into a little bit more detail to explain how this actually works. So when the original packing came in. It was shipped in a box. It was a little bit dented. It was not really packaged well, to be honest. It's a little bit flimsy. It did arrive in one piece, but yeah, I was not really happy. So I put in some styrofoam and that's it. And of course, the package itself was bubble wrapped, sealed, and then also wrapped into an anti-static bag, which was okay. But for international shipping, my opinion, the risk of damage is quite steep, especially if you look at how these couriers 9 out of 10 times are actually handling packaging. I would say a little bit more care would be appreciated. Eventually, it's still $200 that you're spending on this board. You don't want to have it damaged. You need to send it back probably to Romania. They need to do an assessment, blah blah blah, and all that stuff is making it a little bit more difficult. So once it's unpacked, the first impressions, I said, was good. You can see nice and shiny, 3D printed components on top, and on the bottom they added some 3D spacers as well for making sure that the board is not touching your desk when it's seated. Alright, now everything is set up. It's time to configure. So connect to the ESP, it shows up, it's an open Wi-Fi, and eventually if you have an iPhone, it'll basically navigate straight into the landing page. You hit configure, you select your wireless access, you type in your password, and then once that's done and you hit save, the board is actually joined to your network, and you would be able to discover it in the management console. You can wait here, no need to. Eventually it will drop out, and then you'll be joined back into your own normal network, and then voila, an adjusted setup, system booted, joined into the wireless, and we've got a visual, which is awesome. Screws it a little bit up because the voltage is absolutely wrong. So we might want to adjust it later on, but at least we can read the amperage, because the voltage is of course the voltage of the pack and has nothing to do with the voltage of the cell doctor. So next is the installation of the software. So go to MegaCellCharger.com, and once the page loads, you scroll all the way down to the bottom of the page. Not very logical, but that's what it is. And on the right bottom corner you see download. It opens a new window, and then eventually takes you to the download page, and ignore all the stuff because once you order it, it has the latest software. And then download the desktop software onto your machine. It'll be a zip file, so once it's downloaded, you need to have to unzip it and store it on your local drive to be able to run the executable. So locate your download and right click it, then say extract all, and then it will show up a wizard. I've already done that. Click next, 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 finish, and then move the package to your C drive somewhere logical, and start the charger.executable. Once it loads, it has a few drawbacks. It requires a massive screen to actually show all the items. It has no scroll bars. So if you have a 1920 1080 screen, a few of the metrics will drop off. And as you can see, I've already discovered mine, but the process is quite simple. You go to your settings, and you type in your start of your subnet, the end of your subnet, and then you hit discover, and eventually you will browse through your network, identifying the device, and it adds it automatically to your list. Now, by default, when it's discovered, you're not able to set the default values. You need to go back to cell first, and once you're in the cell page and then you navigate back, you will see that you can actually change the parameters. So there are a few bugs here and there which are not that great, and you see it's getting connected. It loads the data, and it starts displaying it. How to work with the UI, I'll get back to that later on, but make sure that you update your cell voltages before you manipulate anything in the system. And by default it's set to, I think, 2.7 volts, which is for the lithium iron cells. I'm using 18650s. I'm not sure why it's set to 2.7. So I'm going to change that, and once it's discovered, it's connected, you can actually load the default values and adjust them accordingly, which is great, because you don't want to accidentally discharge your batteries beyond something that is reasonable or good for your cells. So once set, you hit eventually the save button, parameters are stored, and you're actually good to go. As I was not very happy with the results of the application provided by the vendor, I did some coding today. Started reading straight from the cell doctor the values, quickly configured the database, and connected it to a graphing utility I use, which shows over time what your cells are actually doing. Now, this is really a pilot. I just clicked it together in a couple of hours, and you see on the left, for instance, the battery voltages of the 16 cells that are there at the beginning, I think, of the monitoring. So it's not real time. All the other ones are real time, which has a plot for the voltage, and I have a plot for the temperature, that anything that sticks out is graphically shown. And you also can see the discharge of your cells. Well, that's it for today. Thank you guys, and yeah, until the next video,